All right, guys, so this is the last section of our review before we really dive into the calculus. So let's go over our log functions. So since f of x is e to the x is 1 to 1, okay, continuous and increasing, it must have an inverse, right? Remember we talked about the inverse horizontal test. What happens is the inverse is always reflected across y equals x. So if we have to switch that and everything, and we actually get x equals e to the y, we now need to isolate y. And the way to do that is to have the natural log function, okay? So the inverse of e to the x is the natural log, okay? Now, as you can see with the natural log, the asymptote is no longer at the x-axis, but it is at a vertical at the y-axis. So it keeps getting closer and closer and keeps going out. All right, so logs also can be written as log with a base and then to the x. So usually like on your, so here we go. ln, the natural log, really can be written with the base of e. Log of 10 with the base of 10 can just be written as log x. And that's why on your calculator, where it says log right here, that is base 10. Okay. Yes, we can have other bases, but that is base 10. So let's talk about the graph a little bit. So f of x is log base a of x. A is a base that's greater than 1. That means the domain goes from 0 to infinity. See that asymptote there? And then the range goes from negative infinity to infinity, which makes sense because if they're inverses, their domains and range changes. In this case, f of x is continuous and it is increasing, but it's concave down. All right, and that vertical asymptote, right? So here, this is no longer an behavior. It's actually as we go to 0, as we get closer to 0, what happens is that our graph is going down to negative infinity. As we go to infinity, our graph is going up to infinity. The x-intercept is at 1, 0. Okay, just like for E, it was 0, 1. And another thing to keep in mind is that the base, comma 1 is a point, where before, remember, it was 1, comma the base for E. So let's look at some of these graphs, okay? So we're going to compare the log base a of x to the to f of x of a to the x. Okay, so example, use the graphing calculator. Y equals ln of x and log is in the same coordinate. So we're going to see if there's a difference. All right. So those of you with the TI-84 CE plus or whatever it is, it will be more obvious to you because you could graph them at the same time and have different colors. So I'm going to go and do ln x first. Okay, I'm going to look at the table to make sure. So at 1, it is 0 because, of course, that's where our x-intercept is. At 2, we are at 0.6. At 3, we're a little bit above 1, so on and so forth. And it goes out. All right, so now, and that was just our ln, okay? So now if I do my log, and don't forget, because this log does not actually show a base, it means the base is automatically log base 10, okay? So I'm gonna do log x in my calculator here, and when I do that, yes, it looks like the same graph, but let's make sure those points, right? So of course it goes through 1, 0. But here, when we get to 2, it's 0.3, which is lower. Okay? 0.4. So it comes across here. Okay? So log base 10 is a little bit lower. All right, now without using a calculator, sketch the graph of the absolute value of x minus 2. Now let's remember what the absolute value is. If you go back to your page, because you guys are going to have to keep doing this until you memorize. Remember, the absolute value is on the outside. So it reflects all the points below the x-axis across the x-axis, okay? But leave anything above alone. So we have to remember that, first of all, our vertical asymptote was at 0. But since we are moving it to the right 2, now our vertical asymptote is right here. Now, usually, let me see if I can get my pencil so that way I can sketch it a little bit. So if it was just right 2, this is what we would be doing. First of all, we know that we would be going through 3. Right? Because it was at 1, we move it over 2. And then we would be coming up like this, right? Something like this. This is our ln x minus 2. But the absolute value, remember it said everything under the x-axis we flip up. So it's going to look something like this, and everything above stays. So there is your ending graph. That is in green. This would not be here. I can erase that if I need to. I just wanted to show you what the original was compared to the movement. All right, let me adjust my camera. All right. For changing forms of the equation involving exponentials and logarithms, we use the following form. So this was kind of our last chapter of secondary 3, or second to last, that we wanted you to go through. So make sure that if you were a little bit iffy about learning this stuff next year, that you ask a bunch of questions if something doesn't make sense, okay? So the idea is this. These two are inverses of each other, right? This is how we're related. See where the base is, see where y is, see where x is. Okay, so if we were to change this exponent into a logarithm, we would say log, and of course that base would be 3. Now what happens is that you use the y value, which is 81, and then equals your exponent. So there's your base, there's your exponent, and there's the value. Okay, now I'm going to rearrange this. We know e to the 0 is 1, right? Well, that also means if we flip this stuff around, the base, remember ln, right? And then it says what it equals, and then the exponent is out here. Okay, remember e and ln are the bases. Log base e is ln. Sorry. Let me write that what I was going to say up here. Log base e 1 equals 0. That's us going in logarithm. But you got to remember that e is ln. So anything to the 0 is 1, but ln of 1 is 0. This is a good fact to memorize. Okay, and now we're going backwards here. Don't forget there's no base there, which means it's automatically 10. The exponent here is on the outside, and that equals 0.1. And we can do that in our calculator if we need to, right? Because that would be 1 over 10, and 1 over 10 is 0.1. All right, so some things to keep in mind. Since e to the 0 is 1, that means ln of 1 is 0. And since e to the first is e, then ln of e is 1. The reason why are these cancel out, leaving the exponent of 1. Okay, those are inverses, so they cancel. Because the natural exponent function and the natural logarithmic functions are inverses, this is what happens here. So again, since, like I said up here, since they are inverses, ln and e cancel. ln and e cancel, leaving just n. So we have to keep that in mind when simplifying, okay? So we're going to use that to help us solve some stuff down here. So right here, ln and e cancel, we get the square root of 2. E and ln cancel, we get 3x. Okay, here's the other thing. I'm going to write this over. 10 log and then base 10 of 2. Because don't forget, when the base isn't with the log, it's automatically 10. So what happens is when your base and your log base are the same, they cancel also because those are inverses. So we get the value of 2. Okay, same thing here. If I have a log base 2 and we have a 2 as a base of an exponential there, they cancel, leaving us with the simplified. Okay. All right, here are some properties to help us expand and condense. Multiplication means addition. Division means subtraction. Another way to write an exponent is to write it out front. Okay. Now, we have to be careful when we're doing this because this will help us in the long run. We're going to expand, which means we're going to get bigger. Okay. So if I'm taking these apart, division means subtraction. With that, it means I separate them into 2 ln's. Many of us have a tendency to say, ooh, division means subtraction, so it's ln a minus b. And it's not. And I put a and b, but really it's 5, ln 5 minus ln 8. Okay? This one's a little bit more complicated because we have some issues here. First of all, a cube root is to the 1/3 power. Okay? Now, the only thing I can do now, because I can't expand an addition. I can't have addition and go out more. So the only thing I can do is bring this exponent in front. And we're done. Okay? Expanding means we go from a multiplication division to an addition subtraction. We made it bigger. Okay? If we want to condense, we want to make it one single ln or one single log. So in this step, I have to get rid of the coefficients out front first. Well, right up here, the coefficients out front are an actual exponent inside. So I have ln x to the -3 plus ln y to the 5th. Excuse me. Addition, when we're condensing, means that we're going to multiply them. So we get ln of x to the -3 times y to the 5th. Now we can keep it that way, or sometimes we're going to get in that habit of, hey, no negative exponents, which would be ln y to the 5th all over x to the third. Okay? All of that's inside the ln. All right, how can we make this a little bit faster? Well, first of all, always do those exponents first. So we have ln x to the 1/2 plus ln x plus 1 minus ln y to the third. Now, what I want to show you here is this is a positive ln right here. So that means that this is going to be in the numerator. As in, this is a positive ln. So anything in there is going to be in the numerator. But as you can see in the next one, this is subtraction. So that means that goes in the denominator. This way, it's easier to condense it all at once. So remember, I'm condensing into one ln. So ln x to the 1/2 is in the numerator. X plus 1 is in the numerator. And y cubed is in the denominator. Perfect. Let's move on to the next. Okay, this time we're going to solve. And when we solve things, especially by hand, we do it by doing the inverse operation. So anytime we see an e, we're going to do an ln, and vice versa. Anytime we see a log base, a number, we're going to do that base that number. And you'll see when we get over here. So sometimes we have to, like in B's situation, we have a couple logs there, which means we can't start solving until you condense it into one. So let's focus on A first. We're going to get x by itself. What's furthest away is to subtract the 6. We get e to the 2x minus 5. How do we get rid of e? Well, we do ln. Now, be careful here because you want to do ln y minus 6 in parentheses because we're lning that whole side. So if we ln this side, it gets rid of the e, leaving us with 2x minus 5. Then I have ln of y minus 6 plus 5. So there's two ways we can do it. You could say plus 5 on the end here, and that's perfectly fine. Or you could have said 5 plus ln, depending on how you want to write it, equals 2x. So I'm going to write my final answer up here. I get x equals ln. Don't forget the parentheses. If you forget the parentheses, you don't know if that 6 is really in there or not. And we're done. Okay, on B, remember I said you can't solve it until you only have one log of that base. Well, look at this, subtraction, right? So again, that first log base 2 is positive, so that's in the numerator. And that second log base 2 is in the denominator because it's minus before the log. So we end up getting right here log. Now don't forget to put the base down. A lot of people forget the base 2. And we have x over x minus 8 equals 3. Okay. Now, how do we get rid of a log base 2? Like I said before, what we do is we take the base and put it to both sides. That's why I like using colors for notes, because it shows you what to do. What happens here is these two cancel. So we're left with x over x minus 8 equals, well, 2 to the third is what? 2 to the third is 8. Now we can do some algebra here, right? So I'm going to get rid of the denominator. and I get x equals 8x minus 64. I get negative 7x equals negative 64. So we get x equals 64 over 7. Okay, perfect. All right, changing of the base. Since the only two logarithmic bases in your calculator are 10 and e, you will change bases on your calculator in two other ways. All right, so the truth is, guys, there is other ways to do it on your calculator. After you do this practice, I will show you how, because these are good to know. So if we were to change them in a log base 10, so we could do it on our calculator right on the top of the calculator, that is, what we would do is we would put that inside, log of that inside over the log of the base. Okay, we can do that for ln also. So what we do here with log base 7 and 112, we would do log of 112 all over log of 7. And then we can do that in our calculator. So let me show you that now. And it doesn't matter, you can do the ln too and it'll be fine. So log of 112 divided by log of 7, and I'm going to prove that to you right there. Okay, now let's say we did ln instead. Ln of 112 divided by ln of 7. As you can see, we got the same thing, so it doesn't matter which one you want to memorize. We're going out 3 decimal places, so it's 2.425. All right. Here is another thing that you could do, and I'll show you this. I found it out last year. I think it's in math. Yeah, log base. See how it goes all the way to log base? It means that you can put that base in there. So watch, we had the base of 7, 112 equals, and what do you know? We have it. So there's 2 ways we can solve log that doesn't have a base of 10. All right, so here we go. Find the exact value for x. Now, when it says exact, it means like don't use your calculator to do the decimal places, okay? So we have 3x plus 3 to the x plus 2 equals 6. This one's really hard because before an exponential, we would try to see if there's a same base. But as you can see, there's nothing common between these two bases. So what we're going to do is rearrange what this looks like. Okay, so what we do is we say log base 3, and remember of 6 equals x plus 2. Remember, our job is to get x by itself, so all we have to do is subtract 2 from both sides. Now in this case, I might actually, instead of putting subtracting 2 at the end of it, because that looks a little tricky there, I'm going to put the negative 2 in front. So negative 2 plus log base 3 of 6, and that equals x. Use your calculator to find the decimal value from part A and 3 or more. So I'm actually going to use the log base trick. So I go negative 2 plus, I go over to math, go down to log base, and we have log base 3 of 6. And we get that x equals negative 0.369. Be careful with your work, guys. If all of a sudden you came out with a number like this right here without me figuring that out, you would not get full points for that. All right, we are done with the chapter. When you are done with this homework, there is on the next page, there's a review for the chapter. That's good to do before the test. Now, there's a lot to that review. So only do the questions that you feel you need help on. And the full answer key to the review is on Canvas. Good job, guys.